So for this one that we have over here, okay, so we're going to have the power rule and also the trig function. Okay, so this one we can transform that into cosine of 5x everything to the power of 4. So we can use the power rule, the chain rule, and all in one. Okay, so the derivative of this equation is going to be 4 cosine of 5x, close it, 3 times the derivative of the inside, which is going to be negative sine of 5x, times the derivative of the inside, which is 5. So if you want to rewrite this is going to be equal to negative 20. Negative 20, yes, cosine cubed of 5x times sine of 5x. Please note that the argument of the trig functions, it's not changing at all. Okay, so if you want to double check your stuff, that's how you can do it. Now, for this one that you have over here, you know that this is going to be the same as saying secant of 4x cubed plus 5 everything to the power of 2. Now, if you want to use a chain rule, you know that this is going to be equal to 2. Okay, open your secant 4x power 3 plus 5, close it, power of 1, times the derivative of the inside. You know that the derivative of the secant is going to be secant 4x cubed plus 5 times tangent of 4x cubed plus 5 times the derivative of the inside, which is going to be 12x squared. Okay, so that's what you have for this one. Okay, so I would just leave it like that. I mean, if you want to simplify it, let me write it here. So it's going to be 24x cubed secant of 4x power 3 plus 5. Okay, and we have 2 of those, so this is going to be square, tangent of 4x cubed plus 5. Okay, yeah, so we have everything there. Okay, so this one that we have over here, let's look at that one. Okay, so what are you going to do? Well, it looks pretty intimidating, but actually it's not. Okay, so what's the derivative of tangent? Okay, the derivative of tangent, you know that it's secant square of sine of x times the derivative of the inside. The inside is the sine, so what's the derivative of sine of x? Cosine of x. Okay, so what can you do here to make it pretty? Not much. Okay, so I mean, you can change it like this, but it's pretty much the same. Okay, so yeah, that's as much as you can do. Okay, for the last one that we have over here, you have that f of 3 is equal to 2, g of 3 is equal to 4, f of 4 is equal to negative 6, f prime of 3 is equal to negative 7, g prime of 3 is equal to negative 5, f prime of 4 is equal to 8, and they are asking you to find h of x is equal to f of g of x, and they want you to find h prime of 3. Okay, so what I would do first is, you know that h prime of x using the chain rule is going to be equal to f prime of g of x times g prime of x. Okay, so you know that because that's the definition that we learned on the previous page. After that, you're like, okay, my x in this case is 3, so just replace that with 3, pretty easy. Okay, so you have the situation. Okay, now you analyze, okay, so what do I have? Let me put it here. Okay, what do you have? You have f prime, you have g of 3. G of 3, where is it? They are giving g of 3 here. Okay, so you know that that one is 4. Okay, then moreover, g prime of 3, where's g prime of 3? You know that it's over here, so that one is negative 5. Moreover, you have this situation. Are they giving you that? Absolutely. Okay, so you just plug it in. So you have 8 times negative 5, and this is going to be equal to negative 40. Okay, so thus, what do you have? Your h prime of 3 is equal to negative 40. Okay, and that's it.